Hello, my name is Sarah Kurth. I'm the educator at the Lahar Museum, and today we're going to be talking about the 40th anniversary of the eruption at Mt St Helens in Washington State. On May 18th, 1980, at 8:32 a.m. Pacific Time, Mt St Helens erupted. Here you can see that really the blast only took about 57 seconds. So at 8:32:47, you see the collapse in the on the side of the mountain, and then by 8:33 you start to see more material coming out of the mountain. But what makes Mount St. Helens interesting from a volcanology standpoint is that it exhibited a uh, Palaean eruption, which means that instead of shooting out the top like most people think of, it actually blew out the side, and you can really see that demonstrated very well here in these slides, specifically the very last slide at 8:33:18 a.m. So obviously the lasting effects took much longer than 57 seconds, but the initial blast did only take less than a minute. So a little bit about Mount St. Helens. It is considered to be a composite or stratovolcano, but it's not the only one in the Cascade Range. So composite volcanoes are typically very quiet, but when they erupt very explosively. They're also called stratovolcanoes because of the amount of layers of stuff, so strata, rocks, lava flows, all sorts of materials that build up, causing these volcanoes to reach very great heights, upwards of 8,000 feet high. Looking along the figure at the right, we can see all of the volcanoes in the Pacific Northwest, just in the US. There are more up in Canada, but you can see Mount Baker, Mount Rainier, some of the more notorious ones, and of course Mount St. Helens in Washington. But these volcanoes do go all the way down into northern part of California. So now you're probably wondering how these volcanoes are different from other types of volcanoes. There's lots of different kinds of volcanoes out there, and these explosive eruptions are due in part to subduction. So we all know, real quick geology lesson, the Earth is made out of lots of plates. There's continental plates and oceanic plates. These plates all move around on the Earth. Oceanic plates are usually more dense. They have a denser consistency compared to continental crust or continental plates. On top of oceanic plates, as one would infer, there's a lot of water. So when a denser plate hits a less dense plate, the denser plate is going to sink down underneath the less dense plate. The ocean plate will take along with it water, and that water is the key to causing these explosive volcanoes we see in the Cascade Range. The water that's being subducted down causes partial melting of the crustal material, which creates a magma chamber. As more magma builds up, the pressure builds underneath the crust until eventually there's so much pressure that the overlying material cannot hold it in anymore, and that results in your explosive eruption. A similar analogy would be to think of how you shake a can of soda. When they make soda, they inject carbon dioxide. That's what gives it that carbonation, that kind of fizzy feel. When you shake your soda, you're actually agitating that carbon dioxide in your can of soda, which will cause the can to explode when you release that pressure. So volcanic eruptions of the Cascade variety are very similar to our can of soda, and it all has to do with being located next to a subduction zone. But when a volcano like Mount St. Helens erupts, it's much more devastating than just shaking a can of soda. So for example, Lahars, which are volcanic mud flows. When a volcano like Mount St. Helens is normal and quiet, It's so tall that usually you'll get a glacier or ice forming on the top of it. When that hot lava mixes with that cold water, that water and debris all mixes together into a volcanic mud flow or a lahar. These are the consistency of concrete flowing down the mountain through river valleys at about 60 miles per hour. So definitely not something you want to be in the path of. So you can see in the first two photos how it just took out that road and that car. On the right side, you can actually see the blast from the volcano, and it blew all of the trees. So it killed millions of trees, which then clogged up a nearby lake, Spirit Lake, with all of the debris from that log. Another major component of the Mt. St. Helens eruption was the ash. It got everywhere. So you can see in the top right photo how far to the east the ash from Mt. St. Helens got. So even trace amounts up to a half an inch got as far as Colorado, even a little small part of Minnesota. Obviously much closer, had much more larger downfall. So you can see this is a picture in the bottom of somebody using a snow shovel to shovel out the ash. Now remember, ash from a volcano is not like ash in a campfire. It is rock. So this is really bad stuff, not something you can breathe in. It can really cause a lot of issues for your lungs. It's almost like breathing in shards of glass. It's been known to kill animals instantly. So a lot of the wildlife that dies because of volcanic eruption is because of the inhalation of ash. Very, very dangerous stuff. A little bit of ash on your roof mixed with water can become very heavy and cause your whole roof to collapse. So ash is definitely not one of those things that you want to have just lying around, especially on your property. But it's a very popular commodity. So you can buy Mt. St. Helens ash. Just go on to eBay. You can find all sorts of people selling it in little pieces. You may have even seen something called helenite. People found that if you torched the ash, it actually turned into a really pretty green glass. Once that secret got out, more people began creating it and then faceting it and mounting it into jewelry. Eventually, Dharma Trading Company trademarked the name helenite, but a lot of people use other names. So some examples are Mt. St. Helens obsidian, Mt. St. Helens emerald, emerald obsidianite. The list goes on. But you can see here on the bottom right is actually a raw piece of helenite, or I believe that is actually called Mt. St. Helens emerald. And then you can see the faceted forms up on the top. We always have to remember that with volcanic eruptions, there is the life lost as well. When Mt. St. Helens erupted, 57 people were killed, including geologist David Johnston. He was a Chicago native, grew up in Oak Lawn, Illinois, so not too far away. He graduated from the University of Illinois and worked for the USGS. He was stationed on the north flank of the volcano at the time it erupted. At that time, they felt that that was not an area, although there had been earthquakes and other signs that the volcano might erupt in the imminent future. They felt that at the time that it was far enough away and not in the path of destruction. Unfortunately, that was not the case. His last words anyone heard from him over the radio was, "Vancouver, Vancouver, this is it." Just for your edification, Vancouver, he's referring to Vancouver, Washington, where the now Cascade Volcano Observatory is located. So it is important to remember the people who were lost, but the great thing about Mount St. Helens is that they were able to learn more and be able to work on better understanding of predictors for eventual eruptions. So in the long run, it has been great for the field of volcanology and helping avert this sort of disaster in the future. So as the 40th anniversary of the eruption is on us, it does remind us how fragile our planet is and how our sense of normalcy can be erased in the blink of an eye. This really does come at a truly poignant time for all of us. I thank you for listening, and if you have any questions regarding volcanoes or more questions about Mount St. Helens, please feel free to email me at the museum. My email is listed below, and I will have a link elsewhere as well. So thank you so much. Have a great day.